Hi everybody, welcome to the South Park and Kenosha Pass Railroad. My name is Stephen. Today we're going to continue our talk about controlling servo turnouts through DCC-EX. This is part 2 using latching switches. Now I've actually done this video once before with version 5.0 EX installer. I decided to redo this also because I had some changes that I made on some of the instructions on how I'm doing this. So if you've already seen my video on controlling servo turnouts through switches, you've seen most of this. There's a couple of changes, and here's why you might want to go through part of it at least. One is using EX installer instead of using Arduino IDE. We also use a text editor to make some of the changes and show you what I do with that and which text editor that I use. And also we throw in if close and if thrown commands in here is just as a step to keep the potential of the servo having a continuous torque on the motor, which could burn out the turnout the servo. That is just something that somebody brought up off of my first video, and I did include that in this, so made a change to that for just an update on that. So again, if you've seen my first one, not a lot of change. You can breeze through and see if some of those sections I've got them bookmarked where they might be. If you haven't seen my original video on this, well, welcome and welcome, and I hope you enjoy this and that you find it helpful. And coming up in the near future, we'll do part 3, which will have momentary switches to control servo turnouts and what the differences are between that and the latching switches we're doing today. But anyway, for today, it's just on latching switches. So let's get started. Okay, so we're talking about using latching switches to control servo turnouts in DCC-EX. Here's a basic diagram of what we're talking about and what we're going to do. We're going to have our Arduino Mega controlling a PCA9685 that will be driving our 2 servos. We're going to have 2 switches, and here I'm showing rocker switches, or correction, toggle switches. I will be using rocker switches. You can also use push button switches as long as they're latching switches. And we're going to introduce a very basic turning on and off LEDs, and you can use that to show on a display panel whether you have switches open or closed. And there's more advanced things you can do with that. We're just going to talk about a very basic one LED to show whether the switch is thrown or closed. So let's look at the wiring for this. We've got our Mega. We've got our leads that go up to the PCA9685. We already discussed this in the part 1 video. So we're going to be adding the 2 toggle switches, the 2 resistors, and the 2 LEDs. Pretty simple. Mentioned we're going to be wiring the 2 switches to pins 40 and 41, and the 2 LEDs we're wiring the anode or positive side to 43 and 44. Then the negative or cathode side of the LED will common ground with the switches. All of that can be tied together. The resistors, doesn't really matter if it goes on anode or cathode. I'm actually going to have them hooked up on the cathode on the negative side. Doesn't really matter. But anyway, that's basically it. Just run your leads. In this example, we're using pins 40 and 41 and 43 and 44. Again, in video 1, I put up a little file or a little picture that showed available pins to use on the Mega. So there's lots of pins, different pins that you can use to drive these with. Just you can go back and look at that for reference on which ones to use for wiring switches and LEDs to. So if you remember in part 1 of the video, we talked about addressing PCA9685's. And there are 2 predefined in DCC-EX. And we're actually going to use one of those 2 predefined ones. So we're not going to have to do anything with showing addressing of the PCA9685. In the first video, we also talked about addressing servo turnouts for switch control. We are going to make a change to that because we're going to actually hide the servo turnout. If you remember in the first video, we gave them descriptions that would show up in engine driver. Well, this time we're not going to do that. We're actually hide them because with the latching switch, it overrides the buttons in engine driver. You can't control them in engine driver anymore. So we're going to just hide those because we won't need it anymore, and we'll talk about how to do that and make them hidden. We're also going to do an introduction to aliases. I like to use aliases. It makes things a little bit easier for programming. And all an alias is, it assigns a name to a value. It's a substitution that lets you have readable names for things in your script, such as the pin number for turnouts or LEDs or switches. So we'll give our pin assigned names so it makes it easy to remember. So in this case, we've got two, and this is very basic, but we've got 2 turnouts, 2 LEDs, and 2 switches. So instead of trying to remember, well, gee, turnout number 1 was assigned to this pin and LED 1 was assigned to that pin, we just give it a simple name that makes it easier. We're going to have turnout 1, turnout 2, LED 1, LED 2, switch 1, and switch 2. Makes it easy. That's all I have to remember. I don't have to try and remember which pins went to what. And we'll get into a little more in showing how that works. But this is the command that you do it in DCC-EX. It's uppercase alias, in parentheses, the name you want to give the value and what that actual value is, in our case, what that pin number is. So specifically, we're going to use alias turn1, 100, which will be the ID for the servo turnout for turnout number 1. It'll be on pin 100. Okay, so we'll show that a little more as we get into it. This is different than the description we gave our turnouts when we defined the turnout. That description is what appears in Engine Driver. Aliases do not appear in Engine Driver. They don't appear anywhere. They work in the background. It's just how we address whatever we're assigning the alias to. So as we're using it in the case of the turnout, like I said, this is not the same as what's in the description on the actual definition of the servo. All right, we're going to go basic introduction into sequences, and let's talk about how they differ from automation and root. So sequence, automation, and root are all automations that we use in DCC-EX, in EX Rail. And they're basically very similar, particularly between sequence and automation. The difference is that a sequence is a general purpose automation that is not advertised to Y throttles, such as Engine Driver. So if you want to address the sequence, you either have to address it in another sequence or in an automation that calls it, or what we're going to do is we're going to use the AUTOSTART command. So we're going to have these sequences start anytime we start DCC-EX. This is different than a automation, which is advertised to Y throttle. So this actually puts a button in Y throttle controllers, such as Engine Driver, so that you can launch the automations. And it may be one that sends a train on a sequence of things to happen. It may be send a train on a point-to-point between 2 train stations, gives it start and stop commands and this and that and the other. So that's basically the difference. They work pretty much the same, but the automation shows up in Y throttle so that you can start it at any point. And then the root is an automation that defines a route that is advertised to Y throttles, such as Engine Driver. Again, you have a button, and you can use it to initiate a sequence of setting turnout signals, etc. So let's say you have a main line and a siding, and you have the entry turnout and turnout and the exit turnout for the siding as well as signals. Well, with the push of one button, it'll set the proper position for those turnouts to enter into the siding and set the signals for green or red for the tracks that you want to set. So that's what a route is. It allows you to automate some of that stuff for getting trains through certain routes. We're going to talk about a basic introduction to if closed, if thrown, else, and end if. So if is a conditional statement. Basically, there says if something happens, we'll then do the next set of commands. If closed was specifically to the turnout, if the turnout is closed, then do a specific set of commands. Or if it is thrown, do a specific set of commands. Else is that, well, if it doesn't meet the if condition, then do this instead. So let's say, for example, in our example, it's going to be if we throw a switch, then do some commands, which is going to be to throw the turnout or close the turnout or light some LEDs. Else, if we don't throw the switch, well, then we'll show you what else we're going to do. Every if command must end with an end if. So these are 3 different if commands. Each one of these must end with an end if. Again, we'll show that when we get into writing the program, and we'll show that here in just a little bit. All right, we're going to get into a basic introduction on turning LEDs on and off. I have another video where I talked about controlling LEDs through PCA9685's, where we can fade, dim, do flicker, do some different things with LEDs. In this video, we're going to just use pins straight off of the Arduino. You could be using pins off of expander boards as well, that basically just turn them on and off, plain and simple. Nothing fancy with them. And we're going to show how we do that. We're also going to talk about using the throw and close command for just doing that, throwing and closing the turnouts. This is what makes the turnout actually move. So we'll go over the commands on using that. And we're going to compile all of this together in EX installer and how to upload it to the command station. And then we'll be able to back up those files so we don't have to rewrite every time we want to do this. And again, I'll explain all that as we get to it. It's basically the same from the first video when we uploaded the files to the command station through EX installer. So we're just going to talk about adding our aliases to that, fixing the switches that we need, adding our automations that we want, and get that going. So that's what we're going to do in this video. So let's go on overhead to where we can look at EX installer. We're going to add some files. We're also going to look at a text editor on doing some things and get that started. So let's go over there now. Okay, so we're in EX installer. Went over this in the part 1 video. We're going to skip through some of that where you don't need to really do anything to manage the CLI. If already scanned from my device, I wasn't here before, so I've already got that selected. We're installing the command station. When we created in part 1, we uploaded our sketch to our Arduino. We backed it up so that we can pull that configuration back up. So we're just going to pull that up real quick, and this is the folder I'm in, and I want to just grab the config.h. So we go to the advanced configurations, and there they are. There's those files that are created. It's got the turnouts we created, the HAL devices, the myAutomation where we included those subfolders, and our config file that has our initial setup. So if you remember the first one, we created our PCA9685's. We added 2 extras in the myHAL devices. We don't need to make any changes there. We're actually not even going to use these 2. I'm just going to use one of the first 2 that are predefined in DCC-EX. We define our 2 turnouts. We are going to make a change to this, and I can do it here, but because of some of the things we're going to do is backing up and forwarding, if I make changes before actually saving it, these changes can disappear and go away. So we're going to just leave that as it is for now, and go to this text editor instead. I use Notepad++. I think I mentioned this in the first video. It's a great text editor. One of the things I like about it, let me show you here. I've just got another DCC-EX file pulled up. It color codes as you type things because it recognizes C++ code. So this green stuff up here is remarks. We've got includes and definitions in this red, and then our assignments in blue with what the assignments are. Oranges, it has some different significance to what you're typing in. Particularly when you're typing in some of this stuff, as you type it and enter it, if it doesn't change colors, as you see here, then you can maybe know that, oh, let me check my spelling. Did I type it right? It will also bring up some stuff for you that you can select enter instead of having to type the whole thing. We may see some of that. We'll get to it here in just a little bit. But let's go back to the my turnouts. I've got that pull up here. That's got the 2 turnout definitions, and you can see here the number of assignments are in orange here. The stuff in parentheses, that's our description, is kind of grayed out a little bit. So you can already right there see some of the color coding in it. So in this case, since we're using latching switches, this will override DCC-EX's ability to control the switches. You will only be able to do it with the toggle switches because we're using latching switches to control the turnouts. So because of that, we don't need to see them in Engine Driver or whatever software throttle you're using. So we're going to take out this description turnout 1 and change it to, in all uppercase, hidden, not in parentheses, just typed in just like if it were another part of the command. Okay, so if you can see that, this is the definition, the servo turnout with the ID, the pin number, the thrown position, the closed position, the speed or the profile they call it, and in this case hidden with the description. We're going to leave the second one, turnout 2, the description in, just so that I can kind of show you when we get to the demo what happens by doing it these 2 ways. All right, so now we need to create our 2 new
subfiles that we want to add to this. And the first one I talked about was creating aliases. I remember I like to compartmentalize everything, so I'm going to put my aliases in its own subfile. So you can go back to your file browser and create a text document and rename it like we did in the first video. The second option is to do it here in Notepad++. We'll create a new document. The first thing I'm going to do is just go ahead and save it. So I'm going to check Save As, and here's another feature of Notepad++. It actually recognizes the C++ source file extensions. The CPPs, the .h's, the INO, all that stuff. So we're going to select that and then give our file a name, and we're going to call it myAliases.h. So we've got that file created, and now we're going to actually put our aliases in. We talked about that at the beginning of the video. I've got mine just kind of pre-written up in a little document here, so I'm just going to copy and paste them just to make it a little bit quicker. And we'll talk about what they are. Okay, so if you remember, the command is all uppercase alias, open parentheses, the name you want to give it, and then the number that, or the value that it's going to represent. In our case, these are all pin numbers. So we have, remember, our turnouts on 100 and 101. Our switches are going to be on Arduino pin 40 and 41, and our LEDs are going to be on Arduino pins 43 and 44. I'm just skipping one in between for this demonstration, but that's basically it. So for our two switches, our two toggle switches, I'm calling them SW1 and SW2. Our two turnouts are turn 1 and turn 2. And our two LEDs are pretty simple, LED 1 and LED 2. So we've defined our 6 aliases, the name we want to give it, and then the value that it's associated with, in this case, a pin number. So now, instead of trying to remember, okay, which pin was for the LED and which pin was for the switch, I've given it a name that I know I can remember. SW1 for switch 1, pretty simple. Turn 1 for turnout 1, and LED for LED 1, and 2 and 2 for it as well. So we've defined our aliases. This is what we're going to use to program our switches. Now, one thing to note, remember, aliases do not appear anywhere else. They won't show up in Engine Driver. They won't show up in anything other than they're working in the background and where I type them into the program. All it is to identify a value, a pin number, with a name so that the programmer will recognize it. So let's go ahead and see how that's going to work and how we use it. So we're going to create our next subfile like this. We're going to create a new document, and we're going to save it as a C file, and we're going to call it mySequences.h. Okay, so here it is up here. All right, remember we talked about sequences, automations, and roots. They are all automations. It's just that the sequence does not appear in Engine Driver. It's something we want to work in the background. So I've got my sequence pre-typed. I'm just going to copy and paste it again to try and save a little time. And let's talk about what's in here. So we're giving it sequence and we give it a number. Every automation has to have its own number. Sequence, automation, and root are all considered automations. You cannot duplicate the number. So you cannot have sequence 1 and automation 1. They have to all have a separate number. The only thing sequence and automation does is define whether it shows up in Engine Driver or not, in wide throttle devices or not. So we're giving it our name, sequence 1, AUTOSTART. We want this to run every time DCC-EX starts because we want it to monitor the switch positions all the time to check to see if we want to throw a turnout. Okay, so that's what the AUTOSTART is, all uppercase. Now we get to go into those if commands we were talking about in the PowerPoint. So the first one is just an if by itself. And so I've used my alias SW1 for switch 1. So if switch 1, so what that means is if you turn on switch 1, you put it to the, in our place it's going to be the thrown position or the on position, then this is going to sense that on that pin. We're going to know that pin is going to go high and know that that switch is turned on. So if switch 1, this now becomes a true statement. If that statement is true, then we want to execute what follows it. So the next one is actually another if statement. If closed, turn one. Remember, turn one was our alias for the first turnout. So we want to check, is turnout one closed? Which in this case, since we're just starting, it should be closed. So this becomes true. Then we want to execute what happens next. Throw turn one. Again, we're using our alias turn one, throw it. So we're just telling DCC-EX just that. Throw that turnout. Throw that servo so it throws that turnout. Okay? We also are going to use the set command for LED1. LED is our alias for the pin number for our first LED. Set turns it on. It sets that pin to high so your LED is on. So we've turned the switch on. It's checked the switch is closed. So it throws the switch and it turns on our LED. You can have multiple LEDs. You could have multiple switches theoretically, but you were only trying to throw one. We're only looking at one switch in this case. So maybe we have a red and a green LED to show a open and closed position. Well, you could add another LED here and define it to turn one to red and one to green. You know, you can turn them on and off, and we'll get how to turn it off in just a second. Then I mentioned every if statement needs an end if. We have two if statements already right here, the first two lines. This end if ends the second if statement. So the last if that was defined is the first end if. So we've gone through our if close, checked it, and done what we want to do, and ended that. So then the script will continue. Else, if switch one is not on, if it's not active, then this becomes true, and we execute the commands that are after it. That's what else does. So the switch is closed. Now we want to check the position of the turnout again. If the turnout is thrown, theoretically the idea is the switch was already thrown and we want to close it. So we've just turned the switch back to the off or the closed position. So it's checking, is that switch thrown for turnout one? Yes, it is. What's the next line? Well, then let's close that turnout and let's turn that LED off. The reset sets that pin to low and turns the LED off. Okay, so we've gone through two steps, or three steps, I guess, four steps, multiple steps, I don't know. Anyway, if the switch is on, if the switch is closed, throw the switch, turn on the LED. Otherwise, the switch is not on. Is the switch thrown? If it is, close it, turn off the LED, then end these last two ifs. So these last two end ifs in a row, again, this first one ends this if thrown, and the second one ends the first if. So our whole sequence is now done. So here's why we did the if thrown and if closed. And somebody brought this up. I originally did this video a while back and did it just with setting this up through Arduino IDE. And this is one of the changes that I've made to this video. Originally, I did not have these if thrown and if closed commands. So if the switch was active, it threw the switch, period. The problem with that is that this continues to cycle through. Remember, we're continuously monitoring the switch. And every time it would cycle through this, it says, yes, the switch is on. Let's close the turnout. So it tries to close the turnout. It's moving that, trying to move that servo to close it. And it could put continuous load on that servo. And I got comments that were concerned about possibly burning out the servo because you're continuously putting the load on it. So this way, it checks if the switch is closed, excuse me, then we throw the turnout and we only do it once. So the second time this comes through and this runs, it continues to loop through, it checks again if the switch is thrown. Well, yes, the switch is thrown. Is the switch closed? Well, no, because we've already thrown the switch is now thrown. So it will skip these two commands, end that if, and go on to the next one. It won't execute this because the switch is thrown, so it will skip the else. This part is true, this part is false, so it will skip all of this. We've gone through it once, the switch is thrown, it will skip these three commands, and this could continue to go through. I hope that makes sense. I hope I didn't get too confusing with that. I'm trying to, get through this coding and make it understandable. Basically, if you type this in, it should work. So the next thing is we repeat it for switch 2. Remember, we've got 2 turnouts, 2 switches, 2 LEDs. So all the commands are the same. We just change our aliases to switch 2, turnout 2, and LED 2. That's gone through, and it's going to check both switches, and then it's done. So what happens then? Well, that's what this follow command is. We want it to come up and start all over again. We want it to continue to watch all of these switches and check. Did we throw the switch? Did we close the switch? Did we throw the switch? Did we close the switch? It keeps watching as long as the program is running. That's what this follow command is. So it's follow with the number of the sequence you want to follow here. Since this is sequence 1, we want to follow 1. That's it. That tells DCC-EX how to make switches work. So we're going to save this. We're going to save all of them because we made changes to the mySequences and the myAliases. And we needed to save those. And we made changes to the turnout by putting the hit in. So we saved all of those files. Now we can go back to EX Installer. So we were looking at our subfiles. So right now we've only got those 4 original ones we made. So we need to back up. So we're going to hit the select version and go back. And we've already got it selected. All we need to do is go back and then hit forward again. Now it's got those extra subfiles in it. We've got myAliases, where we defined those 6 aliases. We've got mySequence, where we defined those sequences that we just made. And under the turnouts, it updated it to hidden. In the text editor, we could have done this as well, but we'll just do it here since we didn't do it in the text editor. We need to include those 2 new subfiles we just created. So DCC-EX finds them. So we're going to do # include in parentheses myAliases.h, close parentheses, and then # include is all lowercase, open, not parentheses, I said that wrong, it's quotation marks, my apologies. Open quotation marks, and we're going to do mySequences.h, close quotation mark. And that's it. That's all we need to make this work. So the next step will be to upload this to our command station. So we'll go to our compile and upload, hit the load button, it will compile this. Oh, we've got an error. Let's see what it is. I misspelled something. I see what it is. myAliases.h is misspelled. I forgot the last H. So we're going to go back. Unfortunately, since I hadn't saved the my automations, it deleted it completely. So we need to retype, include. This is a great reason to do it in the text editor. myAliases.h, close quotation mark, include mySequences.h, close quotation mark, and we've got a misspelling here with a capital, so let's fix that. Okay, that looks good. So we'll try this again. We'll go to the compile and load, hit the load. Okay, so it compiled correctly. Now it's uploading to the Arduino. Okay, so we've got a successful install to our Arduino. We want to back up our configure files because we want to save all of that. We're going to browse to where we were, and it's still under that same folder, servo test, that I was using before. Hit the backup. It's going to ask if I want to override it because they're already there. Well, yes, I do. I want to save these new ones. Okay, so that's done. It is compiled, it's configured, it's uploaded. We're ready to do a little demo. So we're going to switch over to that. We're going to set up the command station with the 2 servos and switches, and we'll show how this works and how this looks. Okay, so let's see this in action. Please excuse the crudeness of this setup. This is just a little temporary throwing this together to be able to show these latching switches working with the servos for servo turnouts. So what I've got here in this stack here on the bottom, you can't actually see it, is my Arduino Mega.
And this is just a shield that stacks on top of it that's got screw terminals. This is something that I made just to be able to, again, use screw terminals to latch things in. Then my motor shield and my Wi-Fi module, my MakerFab Wi-Fi module stacked on top. And those are all wired up and set to go. PCA9685 is back there. It's wired as per part 1 of the video with my 2 servos wired to pins 100 and 101. Then I've got my 2 switches with the LEDs and this little mount here just to be able to demo this. I've got my resistors on the back side of it for the LEDs. And it's wired with 2 wires for the switches going to pins 40 and 41 and 2 wires to LEDs going to 43 and 44. And so all that works is now when we flip the switch, and if you'll watch the turnouts or the servos, they should move with the switch. Okay, you can see that second one move and the LED came on as we threw the switch. So when we turn it back off, it goes back and the light goes off. Same thing with the other one. Okay, so if you remember that, what it was is that when we throw the switch, it senses that switch position, and since the servo was in the closed position, it throws it to the open position, and vice versa. So that's all that's doing, and so it's working. And so the other thing that I wanted to show you was we hid one of the servos or one of the turnouts, and we gave a description to the other one. So you can see that just that servo 2 shows up in here. The other one was hidden, so it's not there. And when we press the button, nothing happens, because this sensing the position or sensing the position of this switch overrides it. Since it's continuously sensing the position of that switch, it continually says, okay, we're in the throw position. So it actually sends the command to the servo, and I can actually hear the servo chatter a little bit, which is probably not good. It's putting extra torque and extra drive on that servo that we don't want. So another good reason to have that hidden if you're doing the latching switches, because it doesn't do anything. However, you'll notice that this will change as we change the position of the switch. You can see now it says throw, close, throw, close. It's not actually showing the position of the switch. If you remember, this is supposed to be a button and you would press that to close the switch, but it won't close it again because this is overriding. So the position of the switch is actually opposite of what that shows, but you can see that it's updating DCC-EX even based on the mechanical or the manual throwing of the switches. Well, that's it. Now you have toggle switches, or in my case rocker switches, latching switches to control servo turnouts. So if you've got a panel board that you want to do latching switches for your turnouts, this is how it's done. So that's it for this video. Keep watching. There should be part 3 coming up sometime soon. With that one, we're going to go over using momentary switches instead of latching switches. The difference being that with momentary switches, it doesn't override engine driver, and we would actually be able to use the turnouts and buttons in here. We're able to use EX Rail and automation to send the commands, and it will all keep it updated, from whichever position you throw the switch, whether it be from engine driver, from EX Rail automation, or from the switch. It will light up the LEDs or turn them off as appropriate. It will control the servos as appropriate. It will update the buttons as appropriate, and do all that using momentary switches. So that way it gives you the option of using multiple ways of using servo turnouts. Don't know exactly when that's coming up, but it should be up here pretty soon. Appreciate you watching this video. I hope you enjoyed it and find it helpful, and we'll see you guys soon.